In this lesson, we will walk through the optional texturing test problem answer, where we are asked to add roughness, a constant roughness to this part, varying that noise roughness based on a CAD face, and then as an advanced test, mimicking a metal AM surface. So we have our starter part, which I have as a CAD body variable and also as an implicit body. So the first ask was to add a constant roughness throughout this surface with an amplitude of 0.6 millimeters and a frequency of 100. So in our simplex noise 3D, we'll have a random seed of 1, frequency of 100, and then we'll just multiply the simplex noise 3D by that amplitude of 0.6. The last step is to offset the body. So we'll take our original body, offset it by the noise, and we get something like this, where we have roughness all throughout this part. The second ask was to have that varying roughness based on that CAD face. So we'll again use that same noise. We'll use this noise throughout our part. So we still have that amplitude of 0.6 and our frequency of 100. But now we're going to have a ramp. So you could have done this in a different way. You could have done the simplex noise 3D and then had a ramp where the outmax was the amplitude. But I just am keeping this noise in each one of these examples. So for my ramp, I have a plane that is based on, I'll show that final result. So I have a plane that is at the centroid of our face that we want to use, this smooth face. And it's pointing in that direction we want to see along that Z. You could have also just made this CAD face into an implicit and used that. Either way works. For our in-min, I have a 0. And to ensure that this change is happening throughout our entire part along the Z, I chose the original body dot bounding box dot span Z. So we can go into that original body bounding box and get that information here. So we have that entire span along the Z. You also didn't have to use those variables. You could have used our ruler and chosen a value that seems about right for that. And then for our outmin and our outmax, because my noise I already multiply by 0.6 millimeters, I'm not having units in my outmin and outmax, and instead I just have this go from 0 to 1, where 0 is that smooth face, we can see that final result here, and 1 would be the maximum noise that I want, which is going to have that amplitude of 0.6 millimeters. So that's how we get something like this. And then our final ask was to mimic something similar to a metal AM surface. And this is an advanced question that uses our angle field. So if you did not do this step, that's okay. Feel free to listen to this explanation as one way you could do this. So to show my final result, if we have our build plate, let's say at the bottom, that same face is, we would expect something like this top surface to be smooth, while we have any overhangs will be our areas of most rough region. So in order to make something that looks like this, that mimics that metal AM surface, we can use this angle field. So if our build plate, we expect that the plane from normal would be 0, 0, 1, so pointing up to our part. If I look at this angle field of our original body, type F, and let's look at this with our plane from normal at 0, 1, 0. Or let's do 1, 0, 0. And I'll move this so we can see what it looks like in that hole. So this is a great for doing anything, especially when thinking about overhangs, this angle field, because it will give us the angle that that surface is to our direction. So this bottom surface is 180 degrees. At that top surface we're around 0, and we can see how that is in this hole as well too. So we can use this to then say where we want areas to be more rough versus more smooth. So I have this angle field as my ramp, and my in-min is going to be 0 degrees, in-max at 180. So this is just a simple example. Maybe you would change this around if you were mimicking your metal AM surface. But our outmin is 0. So when we have something that is in that same direction, we're going to have a smooth face like we can see here. And when we have that overhang of 180, we'll have our max value as we can see there. So with that, we can bring that into our offset, and I'm just multiplying our ramp by the noise. We have that as there's the alignment factor, and we get our offset. So that angle field makes this a bit more of an advanced question, but using our ramp, using our offset body multiply, it's pretty much the same thing. We're just using a different scalar field for this. So that's how we would solve those 3 questions.